Okay, we're here to explain problem number 5 on the homework set of the group projects. And so in problem number 5, we're given an intensity at a measured distance. So at this distance, R equals 10 meters, an intensity of 0.105 watts per meter squared is measured. And we are told to find what intensity would be at R equals 23 meters.
So in order to solve this one, we need to first figure out the power of that the speaker or the source is putting out. Just as an explanation, so this is a representation of the distance. So imagine there's a speaker here with certain power and intensity, and that as that goes further away, the intensity changes. And so the radius, or the distance is a radius if you think about the sound going out in all directions. So first of all, we know that the equation for intensity is I equals power over area. And so we'll have to first solve that for power. So the power is equal to intensity times the area. And so that's how we'll find the power. And then once we know that, then we know that the power will remain constant for the other distance of 23 meters. So then we can use the inverse relationship between intensity and distance to find out what the second intensity will be. So for that we use I1 over I2 is equal to, and it's an inverse proportionality. So we'll have R2, and that's squared, over R1 squared. And so solving that for the second intensity, we get I2 is equal to the intensity 1 times R1 squared R2 squared. Yeah, and so those are the equations that we'll use to solve this one.
Okay, so simply plugging and chugging here, we have our I1, which is 0.105, not meters, watts per meter squared, and that is times our radius 1, which we know is 10 squared, and as well as meters. And then we have over our radius 2, which we know to be 23 meters squared, and that will be our intensity 2. And that answer ends up being 0.0198 watts per meter squared. So there's our intensity of that same wave at a distance just over twice as far.